yesterday. Let's just remember what happened. What we were doing was, we were establishing these three guys. We were thinking about what they look like, and how we would have to restrict them so that they would be functions and not relations. Do you remember this? Okay. So you may also remember, say this first one, right? It is it's not the same as just swapping around your inputs and outputs, okay? Because this one's a relation, this one's an inverse function, okay? So we had to think about the restrictions, we also had to think about what they look like, okay? Now the restrictions are what I want you to focus on today. They're the thing which are going to lead us into some tricky issues, okay? So under this heading, I want you to first consider, if we put these two kinds of things together, trig functions, inverse trig functions which we've been thinking out, and trig functions which we already know about. The first one I want us to think about, and you can imagine, there's a whole bunch of combinations of these which we're going to look at in turn. Let's just think about sine of sine inverse of x, okay? Now the question I asked you yesterday, I think, was is it the same as x? If so, why? If not, why not? And if not, why, how is it different? Okay, that was my question, I think. So we're going to try and answer this question. And I think the easiest way to try and approach it is with a table of values. Now I know table of values are kind of like that's a very low tech sort of blunt instrument to use, but I think it'll be helpful, and hopefully the results we establish, they won't just come out of nowhere. I'll talk to you afterwards. Now, on your table, okay, these are the three columns I'd like you to put in. Firstly, let's have some values for x, okay? Now, on the right-hand side at the end, I'm going to think about, well, what's sine of sine inverse of x actually going to be equal to? Okay? You come in late, don't disrupt my students. Especially if you want to count yourself one of them. Thank you. Now, before you get to sine of sine inverse, right? I'm taking sine of something, so I want to work out what that something is first, right? So I'm going to think about that immediately after I get some values, and then I'll take sine of that. So you can see my progression here. I'm just trying to do it step by step. Okay? Right, now, sine inverse of some values. What values should we put in here? Well, if you remember, think back to where we first used sine inverse, cos inverse, tan inverse, right? It was in finding angles, right? So for instance, you might see something like this. I think this is the example I gave you before. 3, 4, 5. And if I said find theta, okay? We can write theta in a whole bunch of different ways because I have all three sides. What's one way I could write it? It's a right angle triangle, right? Inverse tan of what? Yeah, good. Opposite on adjacent. That's fine. Okay. Or likewise, I could write it as sine inverse of 3/5. 3/5. Is this okay? And obviously, I could write it as cos inverse something else as well. Okay. Now, here's my point, though. Tan inverse of something. This is an angle, right? This is an angle. So the things in here are going to be angles. They're going to be our pi on 2, pi on 4, pi on 3, or whatever. Okay. So what values of x should we pick? These are not going to be angles. If these are angles, these are just going to be like numbers, right? This corresponds to the range of sine x. So I'm going to pick values like this. That should do. Okay. Now you can pick other values if you like. I'm just trying to illustrate a point. Now, get your calculator out. Get your calculator out. It'll help. Okay. Sine inverse of negative 1.5. What is it? Who's got an answer? Math error. It's impossible. It's undefined. Why is this undefined?
Because you have a triangle with the opposite longer than the hypotenuse. Yeah.
Yeah. Okay, that's good thinking, by the way. That's minus 3 on 2, opposite on hypotenuse. Yeah, you're in trouble, right? So if you want to think about it in other terms, sine inverse, the domain of sine inverse is from -1 to 1. Right? So you put something outside that domain and it explodes. Okay, so your calculator is like, forget that, get lost, I'm not going to do that. So being that sine inverse is undefined, right? Sine of an undefined number is also undefined. It doesn't have a value. Okay? Alright, so far so good. Okay, what's sine inverse of minus 1? Now I wonder if you can tell me what that is without a calculator. Sine inverse of minus 1. That's the angle. The angle that you will get, if you take the sine of that angle, you'll get minus 1. What does sine look like? Now, don't forget, right? You could think about it like this. There's sine, right? So you're like minus 1. Where's that? That's over here. But that's 3 pi on 2, which is outside the domain. Okay? So where's a place that's within the domain that, that can accept that? And it's minus pi on 2, right? Okay, that's fine. So there's sine inverse of minus 1. Well, what's sine of sine inverse of minus 1? Sine of minus pi on 2. The answer is minus 1, right? That's how we pick the angle, right? So, okay, this is interesting. When we took this, it broke. But when we took this, it just gave us back what we expected. All right, let's keep going. Minus a half. What angle, if I take the sine of it, gives me minus a half? Minus pi on 6. And as you'd expect, if you pop in your calculator, sine of minus pi on 6, you're going to get minus 0.5. Okay? And you're starting to see the pattern, right? I can continue this. This is positive. This is, my lines are dying, but you get the idea. Now, what happens when we get here? The same thing that happened before. Because just like minus 1.5, 1.5 is also outside the domain. Okay? So, sorry, this is going down now. Undefined and undefined. Okay, now, therefore, what does this look like? What does this graph look like? How would you draw it? Being that you've got these, these values, when you start with 1, you end with 1. When you start with 0, you end with 0. Yeah, okay, so draw yourself up a new set of axes. It doesn't have to be huge. Okay. What's this going to look like? Well, if you plot these points, you're just going to get, I think like Richard said, y equals x, right? But it doesn't go on forever because there's parts where it's not defined. It just stops existing, okay? Where are its endpoints? Depending on whether you're thinking about domain or range, right? Well, actually, it'll be the same anyway, won't it? The domain and range of this matches the range of this. Okay, that's what really gives you problems. Okay, so therefore, I'm from 1, 1 to minus 1, 1, minus 1. There you go. Okay. So what can I conclude? I can conclude this is sine of sine inverse of x. Okay. I can conclude this, that if I take this function, it is equal to x, but only in a certain domain, namely 4 minus 1 to 1. Okay? So outside of that domain, it breaks, right? Now this is really important to get, because later on we have to prove identities where sine and sine inverse are going to interact. And you wonder, for instance, if you've got sine inverses on one side of the equation, you're like, can I just take sine of the left-hand side and take sine of the right-hand side? And the answer is sometimes. Okay, if you're in this domain, you can. But if you're outside that domain, you're in trouble. Okay, so you need to pay careful attention to that. So I suppose you might want to note that down. Okay, now I'm going to stop for a moment. We did this for sine of sine inverse. Okay, I want you to replay this whole process, but what happens when we swap the functions around? When we put the inverse on the outside and put the regular sine function on the inside, will it be the same? If so, how come? Like, what? Wouldn't you think swapping it changes something? If it does change something, what does it change? Okay, so I want you to go through the same process. Draw up a table. This time, I'm not going to tell you what values to pick. I'll let you have a think about what values might make sense. Okay, and then have a go at drawing it and maybe sort of drawing up a conclusion just like I did here. Okay, so I'll give you a few minutes to do that. Off you go.